Hello friend, let us discuss about something old topic but in a new way. Let us talk statistics. How these statistics can be learned very easily and very practical way. So let us talk about there in the statistics. Basically, those are doing with quantitative data. They have to go for statistical tests and statistical analysis, some assumptions, and when to use those specific tests. So there we can talk about that. So in specialist statistics, there the tests we are going to deal, that is descriptive statistics and inferential statistics. When we talk about descriptive statistics, there are like mean, median, mode, variance, rank, range, and those things are dealing with the descriptive statistics. On the other hand, when we talk about inferential statistics, where the most of the things are dealing with, we there try to infer the things, try to infer about the data, which the researcher or the investigator will collect data from the population. So he or she will go for infer from that population in the process of data analysis only for the sample. So now again, this inferential statistics having two types. One is parametric test, another one is non-parametric test. So the parametric test, it is when there are some basic assumptions are required, then some guidelines need to be fulfilled, then it is only possible to go for parametric statistics. On the other hand, when your data is no required of any normality or any basic assumptions, so the researcher can go for non-parametric statistics. So parametric tests, there are so many tests are there. So like example, one sample t-test and the other one is independent sample t-test. So paired samples t-test. So there are three types of t-test we can see. So sometimes this uh, independent sample t-test, dependent sample t-test. Dependent can be the pair sample, other name, and one-way ANOVA, two-way ANOVA, repeated measures ANOVA, one-way ANCOVA, two-way ANCOVA. So MANOVA, multivariate analysis of variance, Pearson correlation, simple linear regression, multiple linear regression, chi-square test for independence. Okay, these tests are under parametric tests, and on the other hand, non-parametric tests you can see here. For one sample t-test, we can go for Wilcoxon sign rank test for one sample, where you will get you will get more details about it in our consequence in our later talk or later discussion. So Wilcoxon sign rank test, and then independent t-test will be Whitney u-test, and the paired simple t-test Wilcoxon sign rank test. Uh, there may be a little bit mistake, sorry. One-way ANOVA, their Kruskal-Wallis test, and two-way Friedman test, and for repeated measure also Friedman test. For one-way ANCOVA, you can go for quad test, and two-way ANCOVA, no direct or non-direct parametric equivalence, often quad test with additional covariates. Okay, again quad test only you can go for, and for MANOVA and per MANOVA, permutational multivariate ANOVA. So for Pearson correlation, Spearman rank correlation you can go for. Can delta, or there is another test you can go for that. So we will go on the later stage. So simple linear regression is tail chain estimator for robust linear regression, and multiple regression, non-parametric regression, and for chi-square Fisher's exact test for a small sample size. So here we will see that t-tests. There are, as we have seen, there are two t-tests having three types: one sample t-test, independent t-test, a pair sample t-test. So sometimes it's called two sample t-test also, those which is known as independent t-test, and pair sample can be dependent sample t-test. So now one sample t-test comparing mean of a single group to a known value or population mean. In the one sample you will have the value of population mean, or the population mean will be there. Suppose let us take there is 300 population mean. So now you will collect data from the sample, and the sample will have some data from the sample. You will have single group. From the single group mean and population mean, you will try to compare with the benchmark of that. So when we will in this situation we can use one sample t-test. On the other hand, independent t-test, or especially when we are going to compare male and female like that. So based on comparing in two independent group, there we can go for independent sample t-test. So again, this independent sample t-test having two subtype. One is equal variance assume standard independent t-test, and unequal Wells t-test. So in the later stage we will see it. For dependent t-test also, there are having repeated measure for same individual measure at different times. Okay, for match pair of closely related subject of twin. So we will see this later on stage. Now then the parametric test, when we go for this parametric test, we have to fulfill some assumptions. The normality data are normally distributed. Our data, when you are going to collect data, they should be normally distributed, and it should be homogeneity of variance should be equal, or it should be across the group, it should be equal, or independence, it should be independent, observations are independent, and interval ratio scale. So I will not going to discuss this scale, measurement scale. So measurement scale having three part. There uh, nominal, ordinal, interval, ratio. So nominal and interval, when there is those kind of data, we have to go for non-parametric. But here we are having interval and ratio scale. So for interval and ratio scale, we can go for parametric test, either t-test or either ANOVA, correlation, regression, or chi-square. So for t-test, again, as I earlier said, one sample, two sample, pair sample. Okay. For ANOVA, analysis of variance is one way, two-way, repeated measure. So then correlation, Pearson correlation, not Spearman. Spearman will be in that non-parametric. And regression analysis, when we go for relationship between two variables or many other variables, then two variable we can go for simple linear. When there is multiple variables, we have relationship. Then multiple linear regression and chi-square, having for goodness of fit, expected value and calculated value, and chi-square test for independent group or independent. So we will see in our later stage. So now one simple, our data should be continuous. One, it should be, that is interval ratio, and data normally distributed, observation independent. So this one we will see finally. So now let us go, just simply I will go for this also continue. So more or less all our data should be normally distributed. It should be all continuous. You can see here also continuous, continuous. So our data should be normally distributed, equal, and each same subject matter for repeated measure, and there is no interaction between the two factor unless tested. So more or less all our data should be normally distributed. So now parametric test and their assumption, again I am not going to discuss. So in our later discussion we will see for non-parametric non-binary test data ordinal interval ratio. So now here also saying ordinal. So as we are saying earlier, so in non-parametric test our data should be ordinal. So why interval ratio instead of going parametric? So sometimes when we collect data, our data may not be normally distributed, or although it is interval or ratio scale, but it is because of lots of outlier, or because of this reason our we have to go for non-parametric tests like Mann-Whitney test, Wilcoxon, Kruskal-Wallis, this kind of test. So same like in for other tests also we have to go for when our data is not normally distributed or it is in ordinal scale or nominal scale. So as you have seen tail-send estimator for when data is having outlier, then we have to go for the simple linear regression. So you can see here course cover is one way ANOVA pair sample Wilcoxon, and independent t-test Mann-Whitney, Spearman, Pearson, and the multiple linear regression for non-parametric regression, and chi-square for small sample features exactment, and quad for ANCOVA, ANCOVA, Joey, and MANOVA for PARMENOVA. Okay, this thing. So now we will see our one sample t-test, practically how we have to do this, and some set of data set here. One example I show formula, how we can go for proceed from that formula to an t-table distribution based on how we can take. Now let how to take decisions about whether our null hypothesis accepted or rejected, and now there are some standardized score or thumb of rule table for one tail test or two tail test, that 0.05 or that is 95%, or 0.05 0.01 level of significance, that is 99% of confidence. So here we will see, I will show this below. So I will go for uh, some of the one sample t-test. When we have to go for one sample, the purpose of one sample t-test is that whether the mean of a single sample is significantly different from known or hypothesis population mean. So here in the one sample t-test we will have our population mean. So now our from sample mean or population mean, whether it is any difference or not, that is our main concern. So the formula is uh, t equal to mean minus mu as divided as root n divided by root n. So here x bar is the sample mean and mu is the population mean. So here when you do calculation from the sample, so this will be the mean, and the hypothesis population mean will be there already 300 200 whatever. So now you are going to manage it, and S is the standard deviation, sample standard deviation. So when you don't have population population standard deviation is unknown, so you have to go for standard deviation, deviation of sample. So now here will be sample size and the various consideration. Now for one tail test, for independent t-test we have to go for equal variance, unequal variance. So in one sample t-test we do not need to calculate any test for equal or unequal. You no need to go for have distribution table, no need to check it, no need to confirm it, anything, no need to compare it. So in basically one sample t-test is very easy. The primary concern is the variance of a single sample is tested. So here are some of the basic assumptions of the one simple t-test. It should be approximately normally distributed for small sample size, and the observation of the sample size independent for each group, and data should be continuous. So now I will go for some data here. So let us take example. There is the class 7 academic achievements, some tests. So there I have taken the academic performance of the students, and there I have found in mathematics, there I have overall taken 50 students academic score. In mathematics, how they score, and this is student serial number, student ID, and the first student 78, mathematics and science 85, and English 82, and social studies 90. So overall score is 335 score, the first student. And that's like the second student 25 member, this also score in this way. And other, if you want to take screenshot, you can take it. And for other, you can see here. So for 26 student, 86, 84, 82, 91 score in that four subjects. So here overall 343. So this is that 50 students, how the different subjects they score overall marks. These are the raw score of the student. So now our assumptions, hypothesis mean below. Always remember in one tell test, there you will get uh, the population mean, or the value. Based on that you can, the baseline you will get, based on that you will calculate from the sample, and you can compare with it whether this hypothesis population mean and sample mean is differing or not. So now the question is that, is there any significant difference between the academic achievement of class 7 students and the hypothesis population mean of 300 mean score? So now your score and this score is any difference in terms of academic achievement of class 7 students. The instruction analysis, what you have to do, first 50 students score, your total score you have to find. You, it may be different in your score, maybe for girls and boys all together they score for any particular subject. Uh, so hypothesis formulation, how for null hypothesis, in hypothesis, you will find null hypothesis and alternative hypothesis, two kinds of hypothesis. So null hypothesis we formulate in this way: there is no significant difference between the mean scores of class 10 students and the hypothesis population mean. And the alternative, in that it's not or null hypothesis, we are using no significant. But in alternative hypothesis, there is a significant difference. Either it may be sample score, maybe, or null, it may be the population mean, hypothesis population mean, it may be which, vice versa. So here, as you have seen the data set, now we will go to Excel sheet. So in that Excel sheet, I have found there are these are my raw score. These are the subject ID and student, and there I have found some. These are my the student score. The student score I have found. So in the student score, you have seen that these are the student score. So these 50 students are there. 50 student score I have written over there. Now what you have to do when you have this kind of score, first of all we have to look at the formula for one tell test. So one tell test, one sample t-test, we have the formula t equal to x bar minus mu by s by root square n is the sample size. Now we have to find out the mean of our raw score, and mu already have given 300. Now what is the standard deviation and what is the sample size? Here it is observed mean of the sample size. This is the mean average or mean score of our sample. Assume mean and standard deviation of the sample and sample size. Now before going to that, and we have to go for first mean. We have to go for mean. So how we are going to go for mean? As we know, mean is the formula of the mean. We know where I have written somewhere. Mean is sample mean. Sample mean we have to go for where? Yes, I have written here sample mean. So all I have to do plus overall plus. Once I will do all plus, how much I will go overall do plus, I have got after plus 16153. After doing all the score plus sum of the score, I got this. And then for average I have to divide it observed score, observation overall score and observation I have to divide it by 165 16153 divided by 50. Once I divide it, I will get this value. This is my mean. If you want to calculate in that uh, in your manually, you can do it. I will show it how to do it. So this is my will cut it. This is equal to this is my overall divided by 50. So I got my average of my sample size. Now what I got now average and mu. I have already 300 in the questions. It is given, so 300 I have got. So now I can do the one step. But what about the other step? Other step is S for standard deviation. How I will go for standard deviation? For standard deviation, we have the formula. What is the formula? The formula of standard deviation of the sample is root over raw score minus average whole square root and n minus 1. N is x. Raw score is the first student. What is the raw score? X is the raw score, individual observation in the sample, individual observation of the score. This is the first student score. This is the first score. So this x bar, x minus x bar, my 335 minus my mean score. This is 323. It will be minus. Then whole square I can give. And n minus 1. N is 50. N is the sample size. Sample size is 50. 50 minus 1 equal to 49. So I have to go for this process. So 1 is x minus raw score minus average. So for that I have to go for, this is my raw score. Raw score minus this 335. Sorry, 325. So I will do this minus. I have written here raw score minus mean. Sorry, what I have written. Sorry, it will be raw score. What I have written. Yes. First, I have to write my raw score. This is my raw score. Raw score minus average. So I will click it. So here I have to log it. I will log it. So in the manually you can do for that. So this is my, sorry, to what I have written here. So here let us see. I have to put bracket equal to row score minus main. To give bracket. Okay. Mistake is nothing. There is just have to put bracket unlock and to give lock. Okay. So uh, uh, is there any mistake? Okay, let me see where is the mistake. Okay, there is some mistake. Okay, row score minus standard deviation main. This is my main. Okay, now back to log, the other side log, log. Let's see. Okay, so now this is our uh, standard deviation. We are doing minus, then we have to go for, this is called deviation. Now we have to go for square. So I am going to do square of this value. I did square because here is square. So now I have to go for sum of square. Sum of square here is summation. So I will go for all, I'll do plus of it. After doing plus, I got this. Again, then this is sum of square is another sum of square. I have to go for root over root this Q30. That is a Q30. Yeah, Q30 variance. So for this, I will do this upside one. First, I am doing minus from this minus to this minus. I got this minus, and then I doing square of this because here square is written, because square is written. Then after square I will go for n minus 1. N minus 1 means 49. So I will do this divided by this divided by 49 means this divided by 49. So see, you see this divided by 49, this 49. So once I did for this, I got variance. It's called variance without root over. So when I have to do standard deviation, it means root. root square. Once I will do root square, I will get this. So I wrote root square, so I got this many, this below. So now finally I got standard deviation below. This one already we got. Now finally I got standard deviation, and then n square means 49 square. 49 50 square is 7.07, something like that. So now I have to minus, I will do summation average minus mu. Average minus mu I did this much I got, and then s root square of n, root square of n 50 means I got this below. Now I have to divide this and this below. This and this below, when I divide, I got t below this. So this is finally my one sample t test is over. So now what I have to do after this process? Now whether my null hypothesis accepted or not. For that I have to go for, so to determine whether my t test that let me just reduce. Okay. To determine whether my t-test result, I found 5.44. 5.44 significant or not significant? Is significant at 0.0 level with degree of freedom. We need to compare with t value with the critical t value. Now we have to go for critical t value. What we have calculated value is t value. This calculated value will be compared with the table value. Table value is the critical value. So for the critical value, we have to go for t distribution, because our conception is two tail test and one tail test. So what will be the one tail test? What is the t distribution? T distribution is table value where you can check the critical value based on your degree of freedom, okay, and this 0.0 line. You no need to anything, just you need what level, 0.05 level or 0.01, and your degree of freedom. So let us see the table below. So there are two table here. One is for two tail test, another one is for one tail test. In two tail test, you can see this is 0.05 level. In the 0.05 level, what we have seen 0.05 level here is a 50. So we got 49 is approximate 50 degree of freedom. So degree of freedom 49 means this is degree of freedom, and this is level 0.2, 0.15, and 0.1 and 0.001, 005. So this is for total test. So we have found 2009. So now we can see the distribution table value. So we have found 2 plus minus 2.0096. So 2 point approximate, this is that degree of freedom 49. So what about on 49 degree of freedom at 0.01 level, one tail test? What will be the one tail test? In the one tail test, we can go for there. So this is my 50, 0.05 level, 50 is that 1.67. So 1.67. So now we have to compare our t value, what we have calculated from the data. So now our computed t value, this is much more larger than the table value, because table value is this and this is very small one. This is more, our computed one is more. So there is a difference. And our is there more. When you are doing calculating any data, any collected data collection you have done, then you calculated, you have visited field and you have found your value is more than main table value, only especially for t value. Okay, I'm not talking about p value. P value is another thing and t value is another thing. So we have calculated here t value. So t value is more. Our t value is more. So since our t value exceed the critical value, it is more. So the result is statistically significant. Always remember, when our calculated value or our what we have done, that value is more, that means more significant. If it is less, there is no significance from this value. So we have found here our is more, the value is more. So in conclusion, we can say that um, if it is total test, then our value is more than 2.2, then we reject null hypothesis. Reject null hypothesis means there is a significant. Okay, then for one tail test also we reject null hypothesis. So but here we can say we accept, if we took the hypothesis is our alternative, then we will accept our alternative hypothesis. So this is all about one tail test. So we can go for another test, that is two tail test. Sorry, for we can go for independent t test.